Spirit of Aviation Week streaming is brought to you through the generous support of Dynon Avionics. Now FAA approved for nearly 600 certified aircraft models. Learn more at dynon.aero.
In a world of ancient avionics, one Seattle company is breaking all the rules. Now in airplanes everywhere, coming soon to your panel. There's a reason, pilots. Fly Dynon.
Rated A for your airplane.
Good afternoon, everyone, and welcome to EAA Together. We're live here in Oshkosh with a little bit of workshop sessions that we're doing throughout the week. My name's Mark Force.
And I'm Joe Norris.
And today we're going to be talking about welding. Welding as it relates to building aircraft, be it scratch built, maybe kit built, we'll talk about that, or restorations. There's lots of different ways that you can weld steel and aluminum, and we'll talk about two of the most popular methods today, gas welding and TIG welding. And we've got a couple of rigs set up here, Joe. Over here on the left-hand side is a gas welding rig. Over here is a typical TIG welding machine, TIG welding setup. Old school, goes back to the dawn of man.
Almost,
literally,
yeah, almost. Yeah,
in terms of doing things, right?
Long before they had electric welding, they were already welding with gas.
Sure. And then, of course, TIG welding, not necessarily new, it's been around for a while,
right.
But back in the day you were talking about huge transformer boxes and massive equipment, but with today's computer technology, literally a pick up and walk around.
Yeah, the equipment is so much more compact now and so much more accessible, and of course less expensive than it used to be as well.
Sure.
So whereas in the earlier days of home building, the gas setup was really the only real economical way for a home builder to get into it, because they're going to put something in their own home shop and they might use it for other things other than their project, but it's still fairly limited use unless they're in the business of welding.
Sure.
And the TIG machines were just way more expensive than what a home project would dictate.
Yep.
But now you can buy a TIG machine pretty reasonably. So a lot more of our home builders today are using TIG as a replacement for the gas, and either one will give you a quality weld. Techniques are similar, but not exactly the same, and either one is easily learnable, which is the nice part about it. A little bit of practice on some scrap material, and you can get it down pretty well. The thing to remember with welding on aircraft is you're always welding on pretty light gauge material.
Yeah.
I know some fellas that were welders for years, and they're welding on industrial equipment, big storage tanks or giant beams and all this stuff, and they're big stick welders and they're laying these huge beads and they're great welders, but the first time they tackled something in an aircraft, it was a totally new world for them, because it was so much different as far as the gauge and material and the heat they were using and all that stuff. So it is a little bit of an acquired taste even for somebody that has some welding experience.
Yep.
But it's certainly not anything that's mystical or undoable. It's lots and lots of people have learned to weld to put their aircraft together.
And basically, at the end of the day, we have two things that are doing about the same thing. They're providing a heat source that melts the material that we want to weld together. Right. One does it chemical means, and one does it with electric means.
Right, exactly.
And there's some things you have to adjust because of those paths of using chemical or electrical, basically.
Yep. Right, exactly.
Now there's other types of welding. There's stick welding and MIG welding and spot welding and
and all of those had been used on aircraft, especially in the production atmosphere. I mean, there are some of our vintage aircraft that were welded together with a stick arc welder, like you would see in a welding shop at your local.
Yeah, building a bridge. Or something.
Exactly. So that has been used in aircraft.
Yeah.
It's not totally unheard of, frankly, the MIG welders, which are what are also called wire feed welders, are kind of doing the same thing as the TIG welder. They're using the electricity for their heat source, but instead of having a separate filler rod that you're feeding in with your other hand, it's feeding the wire in. The wire is the electrode and the filler all
rod.
at once.
Yeah. Mm-hmm.
And that takes a little bit of technique to get that to work too. But in high production settings where they're even factory-built aircraft today that are using steel tube fuselages, they'll be using MIG welders because it's so much faster for them to do that. Once they get set up and they get practiced at it, you rip through a weld in no time at all with a MIG welder. welders. So.
It's a little simpler, but it's also a little more challenging to get to the same level of the quality of these welds.
Yeah.
And that's why we kind of default toward either gas or TIG, because you get a better weld without having to spend hours and hours, hundreds of hours.
Yeah, really learning the technique and learning the whole setup and everything. Yeah, so these are the easier ones to learn for the beginning welder.
Yeah.
And so, of course, as you mentioned, the gas welding is the kind of tried and true old world way to do it.
Yeah, absolutely.
Back to the guys that were building airplanes in the 40s and 50s.
Sure.
This is what they were using, and they were primarily tube and fabric aircraft. A lot of steel tube fuselages, obviously steel tube motor mounts and rudder pedals and all those different ancillary things, and so. Most of the builders were using the oxyacetylene gas, which is kind of the common thing up until the TIGs became more accessible.
Right.
So this is the tried and true method that you'll see pictures of in the EAA magazines back in the early days of EAA. Yeah. You'll see lots of pictures of Paul and others.
I was just going to say, I remember seeing a classic picture of Paul, sitting behind the torch, welding away, building one of his baby aces or something like that.
Exactly. Yeah, that's what you'll see in all of those old books and the different pictures and that, up until we get into. I had a TIG machine in my shop already in the 70s, but we had a farm and we were doing aluminum welding, which is where TIG really shines.
Sure.
Makes
it really easy that way.
Much easier really than gas. You can do it either way. You can weld aluminum with gas.
Sure.
But it's just a little different technique again. And so I had a TIG machine. But frankly, I was so used to using the gas welder that when I welded my project together, I did it with gas. Even though I had TIG available, I was just so comfortable with the gas torch that that's what I used.
Yeah.
And the big thing about the gas is, you're using a flame.
Yeah.
So you've got a lot of heat coming out of there, and you concentrate the heat where you want it, but there's heat going everywhere through the entire structure. So the whole thing is going to get hotter. And you have to kind of control that heat spread a little bit and watch what you're doing. The TIG, the electric arc, concentrates the heat right where you're welding, and the rest of your structure doesn't get nearly as hot as quickly. It will ultimately.
Yeah, right.
But it makes it a little bit nicer in the shop for handling the materials and all that stuff.
More contained.
Exactly.
And a striking point to that is when I was watching over our EAA TIG welding workshop, the Sport Air TIG welding workshop that we do here in the grounds. In fact, we do it at Paul's workshop, is where we have those machines set up. But I was watching the instructor going over a demo with the TIG machine, and it struck me that literally he could have been doing that in his living room. Because it's just such a confined and real controlled area, but you would never want to do that. Take a gas welding rig and bring it into your house. The flames and things. So it's really unique in that.
Yeah, and you'll notice that even in the welds, when you weld something, and we kind of clean these up so it's hard to see, but. On a raw weld, when you first finish it, when you weld with a gas torch, you'll see your heat lines will be, a certain distance away from your weld bead.
Sure.
And you weld that same weld with a TIG welder, and you'll notice that heat line is a lot tighter. The heat just doesn't. It is so concentrated. It's very, very precise and very, very clean. And so TIG is really a really nice way to go about it if you can afford the machinery and take a little bit of time to get used to it.
And that's the challenge. It's really a cost differential between the two.
Yeah, if you're starting from zero and you need to get a welder and get started, and you're going to weld something on your project, the gas setup is going to be your least expensive way to get into it. The tanks are typically leased or rented. You don't even have to buy the tanks, and for the welding shop will have those, and you can rent them for just a period of time, or you can lease them over a longer time, but that's just kind of a rental fee or a lease fee. And then all you're really buying is the regulator setup and your torch and some tips and some other tools that we'll talk about here in a minute.
Sure.
So it's pretty economical to get into. And again, it's not difficult, but what you're going to want to do, even with the TIG or whatever, is you're going to want to get some scrap material that is very similar to what you're welding on your project. Same, basic material. It's 4130 steel or whatever, and about the same thickness, 32 thousandths or 40 thousandths or whatever. And you're going to want to just get some scraps of that and just practice until you really get comfortable.
That's key.
And then once once you start welding on your project, you're going to find that even as you progress through the project, you'll see that your welds still continue to get better and better and better. When I look at a project, quite often it just seems like, and this is exactly backwards from the way I did it, but quite often they'll start at the tail and work their way forward in like a steel tube fuselage. And you'll be able to look at the welds on the tail are perfectly adequate, but they're not as pretty as the welds on the front of it because the technique just developed.
Sure.
You know, you got used to seeing what you're seeing, and you got used to the feel of it, and feeding the rod and everything, and just.
And from my perspective, the tail would be harder because everything's converging in small, tight quarters.
And that's what I thought
up
of.
In front,
it's
you've
wide
got
open.
lots of wide open space.
Yeah, so I started on the front on mine, and again, I was welding on the farm, so I had a little bit of a leg up on some of the builders, but still, you know, you still can tell that as you do it more and more and more, like anything else, you just get, you know, smoother and better, and it just, you can just see the progression as you look at the project.
It's like many of the things we do in home buildings, we start out with the basic techniques, and sheet metal too, with solid riveting and things. I mean, you get the basic techniques of how to operate the equipment, how to go through the process, and then it's just a matter of practicing over and over and over, doing practice coupons like this, just square pieces, and all the different
lap welds, joint welds, T-welds,
like that.
And then you start into your tubing.
Then going to tubing, we do a tube where maybe we're doing just the right angle, and then we might do an angle, and then we might do a cluster where there's 2 or 3 coming in together.
Which is what you're going to end up doing on your fuselage if you're welding the fuselage together.
And by doing it out in the open on practice parts, it makes it a lot easier to understand the whole process.
And of course, most of our kit aircraft that are sold today, Vans, Sonics, Zenith, whoever, the welding is typically mostly done for you. So if you're building out of a very well-developed kit like that, you may not even need to get into this at all.
Right. But and that's a great thing because you don't have to invest in another set of specialty tools
and the time
to do it. So it streamlines.
But there are still, as you well know, there's still some builders out there that are building from plans.
Sure.
Some of the aircraft that you might want, some specialty aircraft that just isn't available in a kit, and the only way to get it is to build that thing from plans.
Yeah.
So there's still those aircraft out there being built, and more typically today with the welding is in restorations. I mean, we've got, you know,
a lot of restoration,
antique aircraft and vintage aircraft. A lot of those are tube and fabric aircraft, and you're going to end up doing repairs or replacement of some of the tubes or whatever. And so you're going to get into the welding, or even just making new rudder pedals or something like that.
Or something. You
know? And quite frankly, if that's the only thing you have to do, some of these aircraft, you can't buy a set of rudder pedals for some of these old aircraft. You just about have to make them. You know, and so even if you're just getting into maintenance, sometimes a welder is going to come in handy. Now, obviously, if I wanted to make one set of rudder pedals, I wouldn't go out and buy a welder.
You probably have someone do it for you.
Or go to your local chapter, and somebody in the chapter might have a weld set up, and they can show you how to do it. You want to learn this, you know, you might want to learn the skill anyway. So
and that's another great thing about chapters, where again the camaraderie, the sharing of knowledge, getting together to do things that makes it a very powerful community. And it's fun too.
Exactly. So let's talk about, let's start out with the gas. Since this is the kind of the entry level, we'll start out talking about the gas. And I did mention that you have the cylinders that you can rent or lease. You got 2 cylinders. You've got your oxygen, and you've got your gas, which is typically acetylene. So you've got the 2 cylinders, and then you've got to be able to regulate the pressures of those gases.
Let's put up that slide, and we can kind of see a diagram as you're talking about it.
There's on the screen there, you can kind of see what that looks like. So you've got your cylinders. Each cylinder has a valve on top that turns it on and off.
Oxygen cylinder and acetylene cylinder.
Correct. So they've got your oxidizer and your gas, that's the flammable gas. The fuel, And then each one is going to have a dedicated regulator. So you can't switch them. And in fact, they've set it up very conveniently that you can't switch them because they've got right-hand threads on the oxygen and left-hand threads on the acetylene, so that you can't mix them up because that would not be good.
I thought that was odd at first, but then it made perfect sense.
Exactly, and that's exactly why they do it, because they don't want you to accidentally switch those regulators.
And they're color-coded too, so oxygen is typically green. It will have a green tank, a green hose. The regulator has all the markings are generally in green.
And you'll notice too that the pressures are way different. The oxygen is a high pressure cylinder.
Yeah.
There's over 1,000 pounds, 2,000 pounds of pressure in that cylinder, and then the regulator steps it down to our working pressures.
Sure.
So that you just look at the gauges, and if you see a gauge with 1,000 pounds or more, you know that's an oxygen gauge.
zone, yeah.
Whereas a acetylene gauge is only going to be in the hundreds of pounds for the gas pressure, and then the working pressure is going to be down 15 pounds or less.
Yep.
You never ever want to crank your working pressure on acetylene up above 15 pounds because the gas becomes unstable as it's released at those higher pressures, and you could actually have a flash fire.
Oh, wow. That's
so
good.
You always want to control, and they mark that right on the gauge. If you look at the face of the gauge, you'll see that there's a red line starts at 15, and we don't even run it that high.
Yeah.
But there's just telling you don't ever get it cranked up above that.
And by the way, we're talking about a lot of details, a lot of information. There's a lot of good information we have on our website, the EAA website, under the Hints for Home Builders, but also we have a great book on gas welding and a DVD on that as well,
yes.
and TIG welding too.
Right.
So don't get overwhelmed by all the things we're throwing at you right now.
Real quick introduction that you can do your research on, and we have lots of information out there that'll back up what we're telling you just briefly.
Yeah, and we do have 2 courses on that as well, an EAA Sport Air TIG welding course and an EAA Sport Air gas welding course too. Yep. But let's keep on going.
Yeah, so we got our tanks, we've got our regulators, we've got our hose, which again is color-coded red and black for our acetylene and our oxygen, and it all comes down ultimately to the torch, which is what's going to do our work for us. And the torch is a pretty simple little unit here, and notice the size of this torch is fairly small. These torches come in different sizes. If you're going to do a lot of big heavy welding on farm equipment or industrial, there's going to be a much larger torch.
So I've heard the term aircraft torch.
Right,
so,
which is technically there is no such thing as an aircraft torch. I mean, some maybe might market it that way, but it's just a smaller size.
It's a smaller size,
and
so you can get into things.
Yeah, you don't need the high heat because you're working on very low, gauges, very thin material, 32 thousandths, 40 thousandths, whatever. So you don't need a huge amount of heat. So you're going to use a small tip. Okay. So you really don't need a huge torch body either. So typically it's a thinner torch like this. Depending on the manufacturer, some of the torches will have the valves at the base. Some will have them at the top. More of the smaller torches have them at the top of the torch up by the tip, which is a little handier for making your fine adjustments.
Let's go to our next slide while you're talking about that, and I think we have a diagram of that torch.
Let's see if we can.
Do you want to? Thanks. Yeah, one more.
There's our valves we talked about.
There's
your torch.
Okay.
So that's a nice little drawn diagram of the torch I have in my hand here. Now there are several different manufacturers of these torches, and each one will vary a little bit. There's Smith torches and Harris torches and various other brands. And what you want to make sure you do is whatever torch body you have, it's best to have those tips too, because each one has a little different fittings on how to mount the tips.
Yeah.
And so they're not really interchangeable.
No, they're not. You have to have the
whole
brand
setup,
for the whole thing.
And the other thing to remember about that is that the tip numbering systems vary a little bit too.
Oh, okay.
They all come down to a certain wire size that the little hole in the end is, but they describe them differently. So if you've got a Smith torch, it might say a certain number. If you've got a Harris torch, it might be a different number for the same size.
Yeah.
So what you need to do is make sure you look at your documentation that comes with your equipment and understand what you're getting.
And there's about probably 7 different sizes?
Yeah, I found that there's 3 that you use a lot on an aircraft, and there's a couple more that you might want, a really small or a really big one for certain fine-tuning of different, you got a huge cluster. It's going to soak up a lot of heat. You're going to have to have a bigger head on that, bigger torch head. If you got a really, really small spot as a real, like maybe a tab that you're welding on a tube or something for like a floorboard mount or something, that's going to take a lot smaller one because it's just, you don't need that much heat. So in the books that come with these torches, there's actually usually a chart in there that talks about if you need, if the thickness material is such and such, then you use this size tip.
Okay.
So there's always information available that will lead you,
to whatever you need to do.
And it'll also tell you then approximately what pressure you should use to run that tip.
Okay, so it'll give you some guidelines to start out with.
Yeah, exactly. And then you'll fine-tune that a little bit, but all of these different manufacturers have little handbooks. And they're just, some of them are like even pocket size.
Sure.
And you can look up, okay, I'm going to weld 32 thousandths material, and it says I'm going to use a number 5 tip, just as an example. And then so you get your number 5 tip, and then it's going to tell you for a number 5 tip you use 5 pounds on each side of,
Oh.
5 pounds of oxygen pressure, 5 pounds of acetylene pressure.
Uh-huh.
Most of the torches that we use in aircraft are what they call equal pressure torches. So
Yeah, in fact, here's a quick graphic of,
yeah, there you go.
of what you might see.
Shows you different. Yeah, it shows you
Yeah.
on the left-hand side. It's got your different materials, and then it'll show you which tips you might want to use depending on what you're trying to accomplish across the board there. So
Great, yeah.
all that stuff is available, and we have that kind of stuff in our gas welding books and that.
Sure.
But I say as well, it always with your torch you'll get that information
Yep.
as well. So
Perfect. Okay.
pretty handy that way. So the other equipment you need, of course, now you got your torch, you need some way to light the torch.
Yeah.
And we don't ever want to use an open flame to light the torch. That can cause you some problems. You want
Okay.
to always light it with a spark, what
Yep.
they call a striker. So this is a striker, and they get carboned up like that because when you light it, you usually only have the acetylene open, and that's kind of a real black,
Sure.
sooty flame
It's a lot of soot.
until you add the
Yep.
the oxygen. So basically, all you do is you can see that sparking in there. It's just a flint
Yeah.
in there, and that will light your torch. So you crack your acetylene open. Strike that, you'll get a little bit of a flame, and then you can start adjusting from there. So
Oh,
you
okay.
definitely need a
You don't
striker.
need, yeah, no open flames.
No, just normally a striker.
Keep your lighter in your pocket.
The other side of the story is you're going to need a tip cleaner, which looks like this, and they're just a number of different size wires. They're pretty fine. You probably can't hardly even see them in the picture there. But they'll have a number of different size wires to correspond with the different orifices in the tip, various different
So
wire
as
sizes.
those gets used, they get clogged up.
Yeah, they'll get
Little bits
eventually
on
you'll
them.
get little pieces of metal stuck to them from getting
Yep.
close to the weld, or they'll get carboned up a little bit
Yeah.
just from the flame.
Sure.
And you'll need to clean those off. The other thing, a lot of times they'll get little dots of metal on the face of the torch, and that'll kind of make your flame spray out. So you got a little bitty file in there as well.
Okay.
That you can just basically you're just going to file the end of that tip so that
Sure.
it's square.
Yep.
Okay, real lightly, just to
Yep.
knock off all the slag, so to speak.
And the cleaner itself is not a pin; it's almost like a tiny round file.
It's got little serrations on it,
Yeah.
so you can stick it in, and then as you draw it out,
It cleans up things,
Yeah, it
yeah.
draws the material out with it. So those just come in a little foldable thing you can put right with your welding system
Yep.
there. But it's very important that you have that because as your tips get dirty, it's going to mess up the shape of your flame,
Yep.
which is going to mess up your puddle. So you need to keep those tips nice and clean.
Sure.
So always have a cleaner. And what we've done here, as you can see on the table, we've got several different tips. Now these tips, they do screw into the body here.
Slide these over just
Yep.
a little bit so they can. There we go.
So you can see what those look like. But typically you don't have to unscrew the tip from the head. Normally you'll buy a tip that'll come with the entire mounting system, and it'll look more like this. It'll actually have the threaded portion right on it.
Oh, sure.
So all you have to do to change it is just unscrew
Put
one,
that on and-
screw in the other one. And
Yep.
these are always just hand tight on these. You never put a wrench on these.
Yep.
Always just hand tighten them. And that way you can adjust. I'm left-handed, so I would use it angled more this way.
Yeah.
Some people are right-handed, they would angle it more that way, and you can just adjust that before you tighten the knurl down here. So real simple to do.
Yep.
And then while you're running the torch, your valves are right there, so you can literally reach up with your fingers
And adjust it
your flame.
On the go, kind of.
And of course, the other thing you need, and most importantly, you need to protect your eyes.
Absolutely.
These are very, very, very bright. Either whether it's electric welding or gas welding, you need to
Yeah.
protect your eyes. And there's lots of different ways to do it. We have the goggles like this that just kind of go right on over your glasses. For those of us that wear glasses, some people have the goggles with the elastic strap on the back that they
Sure,
those can go over.
they're
the
like a
glasses.
fully enclosed.
Right, those can go over your glasses as well. But I find for myself, if I use those, my glasses steam up in there, and then it's really hard to see well.
Sure.
The other way to do it, some like to wear just a full face shield.
Yeah.
Kind of a flip up, flip down face shield, and you can get those with the different tintings.
Yeah, so there is different shades or
Yep.
different tints.
Yeah, and
for
typically you'll use a lot lighter shade for gas welding than you do for arc welding.
Yes.
So you can still see what you're doing. You need
Yep.
to protect your eyes, but you still have to be able to see the welds.
Yes, right.
And some people like it a little darker, and some like it a little lighter. So there's several different shades of these welding goggles that you can get to kind of satisfy your own individual needs.
Yep.
So got to make sure you protect your eyes.
Yeah, it's really important. Hmm.
So then ultimately what you do is when you're getting ready to weld, the first thing you would do is turn on your tanks.
Okay.
Now the thing to remember here is that these are different materials. This is a real high pressure material in the oxygen side and a fairly low pressure material in the acetylene side.
Sure.
So the acetylene, when you crack that open, all you do, first thing you do is make sure your adjusters are screwed all the way out.
So just to kind of go through the valve system, this is the main tank valve here, and then this is the regulator valve.
Correct.
So we start with this closed, and this open, which is essentially closed. There's nothing.
Yeah, you don't want any, when you first open the tank valve,
we don't
you don't
have
want any flow going past the regulator.
So they have control over it.
And the important thing to remember here is on the gas side, you only want to crack this open about a quarter turn. That's all you need. So you're working low pressure, so you don't need a lot of volume. And the reason you want to do that is because you want to be able to quickly close this if something goes south on you. So you always want to open your acetylene just about a quarter to a half a turn is all you need. And you'll see the pressure come up on the, supply side.
On the gauge, the supply side has come up to about 250.
250 in there. That's your tank pressure, and of course it's still zero on the working side, so we haven't set our pressure yet. Now, contrary to that, on the oxygen side, this is a very high pressure tank. So like these valves are
several thousand psi.
Yeah, these valves are actually what they call double seated valves, and what that means is it seats closed. Or when you open it, and again we'll check to make sure we're cranked out. When you open it, you want to open it all the way until it stops.
To open both seats.
That's going to seal. Well, that's actually going to seal the upper seat so that it's not leaking past the.
Okay.
So otherwise,
so it's like a piston essentially.
It's sealing at the bottom.
Sealing the bottom, bring it all the way up, and seals the valve
otherwise
body.
You'd be losing material out through the valve body here because it's so high pressure. It would force itself past the valve here. So
Didn't know that.
All the way up till it tightens on the open side. That way you know you're not going to lose your material just out into the air. And again, your pressure will come up. And this tank has about 2,000 pounds in it right now. It's pretty full. And then, of course, we still have zero.
Zero on the other side, So
the next thing you do is we've looked it up in our book, and we know what working pressure we want. So now we set that on the working side. But in order to do that, we have to crack the valve a little bit because the gauges won't read correctly if there's no flow.
You got to have.
So we look at, and I'm going to set my acetylene first. So I'm just going to crack this a little bit.
Just to get some flow.
And then I'm going to crank my dial in till I see, I'm going to look for about 5 pounds for this particular tip.
So we're getting 5 of flow.
So I look for 5 pounds, and then when I shut this off, you'll see that it actually went up a little bit. You can't really see it, but when there's no flow, it kind of back pressures the whole system. So you want to do that.
But you want to do it at the flow pressure.
You want to make sure you know what it's doing when it's flowing, because that's the way you're
where you're going to be going.
So then I do the same thing on my oxygen side. I crack my oxygen valve a little bit, and I crank up my oxygen side until about 5 pounds. And then I shut it off and I'm all set. Now, what I do then is when I'm ready to light my torch, I'd put my goggles on, of course, and then I'd crack the oxygen a little bit just to purge the torch. And then I would crack my acetylene and hit my striker. And what you'll get then is a real orange, kind of a yellowish orange flame and a lot of black soot and stuff going on. And then as soon as you start feeding in oxygen, that soot will go away and the flame will start to turn yellow, and then it'll get into a real kind of a bluish, almost to a white. And what you want to do is you'll I think you've got a picture on the one of your slides there.
Here it comes up.
It's a little hard to see there, but you look on the lower right corner there, you'll see a flame. If you still got too much acetylene, you'll almost see like 3 little cones. There'll be a real white cone, and then there'll be a bluer cone, and there'll be a darker color cone. So it's kind of like stepping stones. As you bring those together, you get them balanced, you want a balanced pressure, oxygen, acetylene, and it'll come down to just a nice little pointed cone, which will be pretty white in color with a little blue edge on it. If you keep cranking on the oxygen, the cone will get shorter and shorter, but it'll get a real hissing sound to it. It'll sound mad, and it is. It's too much oxygen, what they call an oxidizing flame. You don't want that. So you're going to back that off until you get that nice, you get rid of the feather. You don't see the multiple stages. You see a nice little shaped cone that's very quiet and very defined.
So there's a very distinct balancing act between the acetylene and the oxygen, how you're feeding it in and getting it set. Now, do you have to constantly adjust this, or does it kind of stay somewhat stable?
It should take care of itself, because the regulators are going to keep your constant pressure, and as long as you don't bump the handles, it should stay pretty well set.
I'm just thinking so many variables going on.
No, it'll once you get it set and you get everything tuned in, you can start your welding. Unless you bump something, or if something starts to run out in your tank.
I suppose toward the end.
And of course you're going to know that because you're going to watch the tank pressure is going to go down, 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 and pretty soon you're going to know, hey, I need to get that refilled. So that's basically all it is. You balance that flame with your torch here, so you get that what they call the neutral flame. It's equal oxygen and acetylene. And that's that nice, it's a nice cone shape, there's no noise. It's not hissing real loud, but it doesn't have that longer dark blue or almost orange feather because that's too much acetylene.
Okay.
So you just balance it out to that nice neutral flame,
Yep.
and then you go ahead and weld. And when you're welding, you don't want to get the tip of that nice neutral flame. You don't want to stick that into your weld puddle. You want to keep it just outside the weld puddle. You get as close as you can to get your heat concentrated, but if you stick the flame actually into the weld, it's going to pop and bubble.
So it starts kind of disturbing the metal.
It disturbs your weld puddle.
You want to get the heat from that tiny tip, but you don't want to have it
blowing everything apart on you.
Exactly.
And then once you get that going, you'll watch and your base metal will turn a nice bright yellow, and then pretty soon you'll actually see it start to melt. And then that's when you start putting in your filler rod, which is with your other hand. You got your torch in one hand and your filler rod in the other hand.
Sure.
And you just go ahead and weld.
Okay.
When you're done, to shut the thing down, what you're going to do is you're going to first shut off your gas. And again, this is just
at the main valves.
At the main valve. And before you do anything here, you're going to bleed all the pressure out of this system.
Okay.
So you've not touched your regulators. You've just shut off.
So this would still be on.
Yep, everything's still on.
It's going to be burning whatever's left in the line.
Well, you can shut your torch off and stop your flame.
Okay.
And then shut your main source off.
Sure.
And then you're going to crack the valve and just bleed it down until all the pressure disappears out of the regulator.
Sure. And I saw on the regulated side
down to zero.
that
as soon as it goes down to zero, you can shut this again and then back this all the way out until it's loose again, because now you know your regulator is shut off. So again, you can walk through the system.
Okay.
And I do the same thing on my oxygen side. I crack the oxygen open. Takes a little longer to bleed down, so I'm going to just crank up the pressure a little bit to get a little more flow just to bleed the system out. And that bleeds down to zero. Once it bleeds down to zero, you back your regulator out and you're all set.
Great.
So that's basically the process.
Yeah.
And like I say, a little bit of practice and away you go. And now filler rods. We need to talk a little bit about filler rods.
Yeah,
as well.
so we've got an example of some filler rod. And there is actually lots of different filler rods.
Yes.
From stuff you buy at the supplier to, I hate to mention it, but coat hangers.
And I wouldn't use that on an airplane, but on a quick repair on a farm equipment, that might be all you've got. It will work.
Exactly.
It will not work well, but it will work.
So let's talk about filler rods. They're basically different alloys, right?
Correct.
Of steel. And depending on what you're doing, you'd pick and it's gauged by the strength of the alloy.
Right.
Basically.
Yeah. Depending on what material you're welding. Again, you can go into your welding books, and they'll have suggestions in there of what type of filler rod you might want to use.
So I've got a bundle of filler rods here that we'll just kind of look at. Now, there's also different diameters too.
Right. Yeah, and the thicker material you're going to use, the larger diameter rod you're going to use.
Okay.
And again, that'll be talked about in your welding manual.
Yep.
It'll give you a range of what size rods you want.
Sure.
But this is the type of size rod that you're typically going to use on your thin wall aircraft tubing. It's the rod is almost equal in thickness to the thickness of the material you're welding.
Yeah, we're looking at like 1/16 of an inch or 40,000.
3/32 or something
like that. Yeah. Mm-hmm.
And typically we're welding 4130 chromoly steel. Depending on which welding expert you talk to, some say you should use a chromoly rod. Others say that that's a little too brittle, and because it's an airplane, you want a little flexibility in the welds. You want a little bit of elasticity. So most of the aircraft that have been welded together over the course of time have used a mild steel rod to weld 4130 to give it that little bit of elasticity. So the old original standard one was the Oxweld number 7, and an Oxweld company isn't there anymore, but you can still get an equivalent rod to that.
Yeah, and they call it the number 7.
Yeah, the number 7 rod. Mm-hmm. And that's the one that I use for all of my projects. It works very well. It's a very easy rod to get to flow properly. It makes a real nice clean weld. And most of these tube and fabric airplanes have been designed back in the days before computers and before any of this real detailed engineering. So they typically built in a little extra strength in them anyway. Just for mama. And so the Oxweld 7 or the number 7 rod is one of the most popular ones that we'll see in the welding industry for aircraft welding. So you've got your torch, you've got your gas for your flame and for your oxidizer, you've got your tip cleaners, your striker, your eye protection, and your filler rod. And you're pretty much all set to go for gas welding.
So there's some special techniques, or I wouldn't say special techniques, but ways that you're holding things when you're welding.
Right.
So how do you do that? I mean, is it...
There's lots of different ways to do it. Typically, if you're welding a large structure like a fuselage or something, you'll have a jig that you'll have it in to get it, all the tubes in position.
Well, that's important too, because you got all these things that can be moving around. You don't want them to warp or bend or get out of alignment.
Right.
So.
And we have, you'll see in a lot of our videos and in our books, they'll talk about different fixtures for holding stuff in alignment while you're welding. But typically what you'll do is before you do the finish weld, you'll go through in what they call tack weld all of those stations. So you just put a little 1/8 inch long,
tiny
little dot that you'll just start the weld and just to hold everything together temporarily so that you can get it all in one 3-dimensional part. And then you can start at one end and
kind of like tiny clamps, but it's actually part of the weld.
Part of the weld, yeah. And so then you'll just tack weld it all together. And this is typical whether it's gas or TIG, either one, do the same way.
Yeah.
And you'll just tack weld all those different stations to make sure everything's kind of held in place. Then you can take away most of the jigging and get it out of your way so that you can get in there and see what you're doing.
Sure.
And then you can go ahead and start your welding. Some people start at the tail, some people start at the firewall side. Doesn't really matter, whatever's most comfortable for you.
Yeah.
And then you just work your way back station by station by station and weld the thing
And
together.
these jigs or fixtures are very similar to our wood fixture where it's basically, a lot of times it is just a piece of plywood with some maybe like 3/4 by 3/4 blocks that are tacked to the, holding things in
and it
position.
depends on, if you're going to use the fixture, obviously the companies that are going to build these things commercially are going to build elaborate fixtures that they can use over and over again.
Yeah, right.
But if you're building just one aircraft, you're probably going to build a temporary fixture out of wood.
Yeah.
And it'll be,
that will be enough to do it.
You don't have to worry about it.
Yeah.
So, it's really pretty simple. The whole technique is just getting yourself used to looking at the puddle and kind of timing the feed of the filler rod to get the nice penetration.
We've got a quick graphic that we can look up in terms of like gas welding where the person's holding the torch and the filler rod. And then as we looked at that again, it gives you kind of an idea of what's happening where the filler rod and the torch and the actual part that you're welding are kind of coming together there.
Right, exactly. Yeah. And the whole balancing act is, and what you develop as the skill is just the timing.
Yeah.
I get the torch in there and I get my metal hot and then I get my puddle started and you start feeding your filler rod in and it's really just a timing thing. How fast do I move? How much filler do I feed in? And you'll end up with a nice bead on top and good penetration on the bottom. And that's what you're practicing when you're doing.
And that's handiwork. That's training your hand to.
And it's a hand-eye thing.
Yeah, exactly.
What you're doing.
Yep.
So that's pretty much what we talk about when we talk about oxyacetylene gas welding.
Okay.
And the Tig machine just basically removes the gas and all the regulators and stuff and uses our friend electricity to make our heat.
So kind of in reverse, just quick because we have these out, we're still using filler rod for TIG. Okay?
Correct, it's the same exact technique.
Same materials.
It's just using, the electricity for your heat source instead of having to light a torch.
So we have filler rod, so that's important.
Yep.
We don't use a striker.
No, don't need to light it.
We don't have to light the chemicals.
Pull the trigger and it'll go.
Right. We do, so we have the TIG torch, which we'll bring out over here.
Yep.
So just to compare the two, similar but totally different.
Well, they do call it a torch, so that should give you an idea that you're doing a very similar process.
Right.
Your heat is coming out of a handheld torch.
Yeah.
Simple as
so
that.
Basically, the TIG torch, as we're looking at it, and I'm going to also get a slide up here in just a second here. But basically, the electricity is going through the torch, and you have actually a ground clamp, which I will bring out here, to make the other connection, because electricity you have to
you've got to complete the circuit. Exactly.
Yeah, right. So basically, we would clamp the clamp on the workpiece.
Yep.
Actually, what they would do is have it on a steel table.
Sometimes that's the best, unless if you're welding on a fuselage or something.
So we have one power lead, the ground essentially, coming to the workpiece. And then with the TIG torch, we have the electrode is connecting the circuit.
Yeah, that's what's making your arc, which is where your heat comes from.
And that's what gets the weld going. Yeah.
Yep. Yeah, and inside this torch here, which you're not going to be able to see real well, but inside here there's a little piece of tungsten, which is your actual electrode itself.
And if we go to this slide, we have kind of an exploded view of what a TIG torch looks like here.
Yeah, there you go. There's your torch. Shows you your tungsten electrode and all of the parts that go into making up that torch. You can adjust the length of that tungsten depending on if you're trying to get down into a cluster or if you're welding something flat. You're going to want to set that length a little bit different because of the access.
Yep.
The thing about the TIG is you've got a shielding gas.
Yeah, so there is gas involved.
But it's not for making heat.
Yeah.
It's actually for shielding the weld to keep out any contaminants.
Sure.
So it's an inert gas.
Okay.
Typically argon, sometimes CO2.
Keeps the air out
it's flowing along next to your weld and around your weld so that it keeps any impurities in the air from impregnating that weld and degrading its quality.
Yep.
So you've got like a gas shield.
Okay.
And that's what TIG stands for. It's tungsten and inert gas. So that's where your TIG comes from.
Yep.
So tungsten is your electrode and the inert gas is your shielding gas. And again, typically it's either argon or CO2 or something like that. So you've got your torch is where your heat's going to come from. You're going to strike an arc between your work and the torch head here.
Yep.
That's equivalent to the little flame you set on your gas torch.
Yeah.
And then you're going to feed your filler rod into that puddle that you're creating with that heat.
So you're melting the metal, but you have to add metal to get
build,
everything
to build, otherwise the metal is going to melt away.
That bead,
You need to have some strength there when you're finished. Otherwise, you're not going to have enough material.
So if we look at the TIG machine itself, there's a couple of things that are similar. We have a regulator that we're going to connect to the shielding gas, and typically it's argon for most TIG work.
Right.
Same kind of thing. We have the high pressure gauge, but we have a different type of flow meter essentially. So we're watching the flow, we're regulating the flow, but it's like a floating bubble.
Yeah, it's kind of like one of these deals where the little silver ball, depending on how much pressure you got going through here, it'll rise up and show you where the flow is.
Yeah, so that's something unique to the TIG machine that we do with that.
Yep.
Okay.
And again, your torch manufacturer will tell you what they want for flow.
Yep.
As far as this one has argon on it here.
Yep.
And also has carbon dioxide.
So there's different gauges depending on what you're doing.
This one can be used for either argon or CO2. So a nice multi-use gauge there. So you adjust your flow of your shielding gas.
Yep.
And then you control the power to the electrode couple of different ways. Typically, most of your machines will have a foot pedal, which is like a gas pedal in your car, an accelerator, so to speak.
Sure.
And so you'll set the range of what your kind of
maximum
minimum on your gauge here on the machine with the knob, and then you'll be able to vary that.
And there's a little readout here. We don't have it plugged in, but
you'll be able to set, if you want real low power, you're going to turn that knob down, it's going to give you a lower range.
Yeah.
And if you want higher power, you turn the knob up, it'll give you a higher range, and then you fine tune it by how far you push.
So the power range is set by the material thickness, basically.
Correct.
So
and again,
thin material, you're going to have a
way
power.
lower power.
And then so you set the power, say 20 amps.
20 amps or 25.
So
or 15
once that's set, the gas pedal essentially, when you aren't doing anything, is at 0 amps.
It'll go from 0 to
and
whatever
then
that maximum.
whatever you push down all the way is the maximum that you set.
Correct.
So you have some control over that.
And you'll need that because as you weld a part, it's gonna gain heat. I mean, you're putting heat into it, so it's gonna get hotter. Which means you're probably gonna ultimately have to just back off a little bit as you go because your joint is gonna get hotter, your puddle's gonna get hotter, and if you get hotter and hotter, pretty soon it's gonna blow away on you. So you're gonna need to start heavy to get the heat in there, and then throttle back as you go to keep a constant flow with your weld. So that's how you use the foot pedal. Now the other way to do that, which we don't have here on this particular unit, but I have one at my house that instead of using a foot pedal, it has a little knob right on the side of the torch.
So it's a finger control.
So if you're in a really odd position where you really can't be working a foot pedal and welding, you can do the same thing by turning a little knob on the torch. It's a different.
I mean if you have to be hanging kind of upside down
and welding,
that
works. They actually have adapters that you can put on these torches that some of them are a slide switch and some are a knob.
But
it just basically replaces the foot pedal with a hand control unit right on the torch. And so you throttle up, start your weld, and then as you're welding, you just back off by either turning the knob a little bit or sliding. Either way, I prefer the hand one. Some people prefer the foot one. It's all what you get used to and what your equipment offers.
And some of the other things that are neat about the TIG torch is normally the head is a flexible torch. So you can get it and twist it around if you have to get into kind of a weird area.
It's very, very much handy for getting into like some of those tight clusters.
And another thing that's adjustable too. This black thing is called a back cap. It covers the the tungsten, and that can actually be taken off. Let's see if we can do that. Yeah, and then replaced with a shorter version. So here's the tungsten electrode.
Yeah, which you're going to ultimately wear out.
It keeps on moving. You're moving it forward.
Yeah.
But you could use a shorter piece and use a smaller back cap. So if you need to get into an area that is tight quarters, you can adjust that too. So it makes a lot of flexibility. And then torches themselves, you can get all different styles, from really teeny weeny ones to
big
real large ones.
You know, depending on what you're welding, just like the gas torch.
Yeah.
If you're welding a really heavy material, you're going to go with a bigger torch, and a thicker tungsten and bigger filler rod. For aircraft work, you're going to go with a smaller torch like this and smaller filler rod.
And speaking about heavier material, if you get into really heavy stuff, this is an air-cooled torch. It's using air to cool the components.
Right.
But you can actually get a torch that has a water line in it, and it's water-cooled to keep the torch components cool. But you really only need that when you're doing really heavy stuff.
High production, where you're going to weld a long time on heavier material. The little welds we do in aircraft, you're typically not welding for a long period of time at once. You're welding a part of a cluster, and then you're repositioning and welding another part, so the torch has time to cool off. So, of course, the other thing you need that we haven't talked about yet is eye protection.
Yes, right. So we have an example of that here. Our Lincoln Electric. So this is a welding. A welding visor.
Can be used for any type of electric welding.
Right. So the unique thing about this, as compared to an older style visor, is an older welding helmet. You know, the kind that everyone has seen from cartoons to whatever,
and everything else.
Has a solid shield. It's a shaded material, and it's basically something like this
built into a helmet
and a big plate, always on. Okay. So what's unique about the newer style welding helmets is they're electronic.
Right.
So how does that work?
Basically, what you have here is you've got a kind of a liquid crystal display almost. I'm not sure if that's the actual technology, but you can kind of think about it that way, where it can go from clear, so you can see right through it just like I'm looking through my glasses. And in an instant, when you strike your arc, it can go down to whatever dark shade you've set.
So there's a little light sensor in there.
Right at the bottom here, there's actually a little photocell. And as soon as that arc strikes, it picks up that high bright light and it darkens that lens for you.
Okay.
And the way that helps you is, instead of having to flip your helmet up and try to find where you're going to weld and then try to flip the helmet down and hopefully it stops right in front of your face like it's supposed to, this one you can leave the helmet down, look right through the lens, get yourself all set up, strike your arc, and you're all set.
Sure.
And then on the back side of it, there's actually adjustments for how quick it'll react and how dark it'll get. So again, some people like it a little darker, some like it a little bit less dark, depending on how your eyes adjust to that. And if you're using a real big flame, you're going to want a little darker anyway. If you're doing something really light, you're going a little lighter because you don't have as much brightness there to work for. So all of that's adjustable in here, and also the time after you get done with the delay before.
So as that metal is cooling down, it's still kind of bright. And
and so you can set all of that on these electronic ones to your liking. How fast does it react? How fast does it shut back off? How dark does it get? All of that stuff is adjustable on these. It's really slick. And some of these are even light enough that they'll get light enough that you can use them for gas welding as well.
Oh, okay.
They're a little heavy and bulky for that, but they can be used.
Sure.
Normally you go with something just
with
like we showed.
Lighter shade,
So, but this is really, really important. It's important with both, but it's especially important with the arc welding because it is such a bright arc that you can
actually start burning your eyes.
You'll damage your eyes quickly if you don't protect them. So you'd have to have a decent welding helmet. It doesn't have to be the electronic kind, but these are affordable enough now that they're really slick. And so most of the folks we know that are building are going to this type of a helmet.
Yeah, and welding helmets are personal, just like a lot of equipment. You can buy the $100 electronic version, you can buy the $500 version. And it's not only just the quality of the shielding device, but it's the actual shape and size and comfort.
What type of a head band it has in it. This one has a real nice sweat band in it, and it's very adjustable. Some of them are a little bit more rudimentary than that.
So different ways you can go with it.
Yeah, exactly. And then a lot of the folks I know, of course, we home builders like to customize everything, so pretty soon you'll see all kinds of neat paint jobs on their helmets and, and everything else. So there's ways you can kind of personalize even your equipment like that too.
Sure.
So the equipment is a little bit more expensive, but again, it's doing the same job. If you're going to do a lot of welding, or if you have other uses for welding, it might be important for you to pick up a TIG torch, because they are, you know, multi-talented. You don't just have to weld aircraft with them. You can weld anything that's weldable.
Yeah.
There's a welder that'll take care of it.
So you mentioned before, well, first of all, kind of wrap up the big picture of the equipment is they've gotten much smaller over the years.
Yes.
And power-wise, the power requirements have changed dramatically. You used to have 220 and huge amperage, and now basically you can plug them into a wall.
Yeah, the smaller units like we would use for aircraft welding, you can run off of your household current. You don't need
so you don't need a special high voltage or multi-voltage plug.
Typically, the smaller units like this that are made, you know, kind of specialized to the lighter gauge materials, you won't be able to weld a bridge together with this, because it doesn't have the upper end that you would want for that.
Right.
It's basically for your smaller jobs.
But for home builder, for most of the things we're doing, I mean, it's very rare that we're going to be welding 1/4-inch steel or something like that.
Exactly. So it's real handy to have a nice compact unit like this. It's easy to move around. You don't need any special power to run it. All you really need is the unit and the tank of argon,
the shielding gas.
The shielding gas, and you're pretty much set to go. And the process is the same as far as when you're first getting started. Get yourself some scraps, make up some little coupons, start, you know, really what you start with is just a flat piece of metal, and you don't even glue two together. You just run a bead down that metal and get used to what it looks like as it's melting, how fast you feed filler in, get all that done without even joining two pieces. Just practice on a flat sheet. When you feel pretty confident with that, then you take two flat sheets and butt them together and try to weld them.
Yep.
And pretty soon you get confident at that, then you can try to do a T, which is a little different because your heat flow is a little different.
Sure.
So you learn all the kind of step by step, you work your way up from just basic bead running, which is, you know, you're just kind of starting out, get the feel of it.
Yep.
And then you work to more and more complex joints.
Sure.
And when you get your practice coupons that look pretty good, then you're ready to start on your aircraft project.
So we've been talking up to this point, typically welding either gas or TIG using steel. 4130 steel is typical aircraft construction.
Right.
But we also mentioned that you can do it with aluminum as well. You can weld aluminum. Now, aluminum welding has been done for, you know, forever with oxyacetylene and doing other things, but it's very challenging. That's more of an art form.
It is, very much so.
You know, I've watched some of the demonstrations that we've had here at Oshkosh over the years, and I mean, there's a lot of magic in
it. There's a lot of smoke and mirrors. But it is. It truly, to watch a person that's really adept at gas welding aluminum is fascinating to watch. It's very, very interesting.
I mean, I've seen them weld soda cans.
I've never quite figured it out myself. So the TIG torch is the way to go for me and for most of us.
In terms of welding aluminum.
To weld aluminum. And the real difference is you're going to go to an AC setting, and these machines will do direct current.
So that's the difference is you've got direct current for steel. And then AC alternating current for aluminum.
For the aluminum, and
that's switchable and programmable.
The newer ones are all set up so you basically just switch your AC or DC, and it's all set up kind of automatically. Our older machine that I had back on the farm, there was a couple other things you had to.
Well, that's the neat thing about it, is the way they're doing these now. If you look at a Tig machine of old, you had like 30 different dials that you had upset.
It was a little
get
bit
everything fine-tuned.
It's kind of like you ever see the flight engineer station on a Convair or something.
Yeah.
All these gauges
and
dials and buttons and stuff. And
now it's just the control.
Turn it on and away
and go. Yeah. So that's all programmed. There's presets. You can fine-tune a lot of those variables, but they've already been preset at the factory for typical conditions, and you basically set a preset or select a preset for what you're thinking of doing, and then go from there.
And it'll explain to you in your manual that comes with the equipment. The biggest difference, as far as other than going to AC on your machine, is on your electrode. Use a fairly fine pointed electrode for steel using DC.
In fact, we have a little picture of that. First of all, just real quick, we'll run through DC polarity in terms of how that works with steel. DC positive, there's DC negative, DC positive, AC polarity. And again, we're getting into a lot of technical stuff that is best suited as a deep dive by taking our TIG welding course.
And most of this stuff will be in your manuals and your videos, your TIG course.
We get into the sine wave and how that all works. But ultimately, as we're talking about the tungsten, okay, so the tungsten itself, we're actually going to be shaping that depending on what you're welding.
Correct, yeah.
So for a steel, we're doing something like this,
like
we're showing in the
like
graphic.
a fairly fine point, yeah.
Yeah.
You're just going to take that on your grinder
Grinding wheel.
and shape it like that. But that's for direct current.
Okay.
When you go to AC,
We have to do something differently.
You don't want that real fine point. You want a kind of a ball tip like this.
Okay. So how do you get a ball tip?
What you really do is you crank up the power really high, and you strike an arc, and it'll actually get hot enough to melt the
tungsten.
Melt the tungsten.
And it creates a
little ball of tungsten on the end rather than just that sharp point.
And then you're set.
And then you're ready to go back to your normal settings, and
very simple.
Away you go. Yep. So that's pretty much how we do it. Again, most of your welding on your aircraft projects is going to be fairly thin wall steel.
Yes.
It's going to be 32 thousandths, 40 thousandths, maybe something even a little lighter than that, depending on what you're making. So you're going to be using the direct current setup with a real pointy tungsten and fairly low power. It's going to be very, very similar in technique to what you're doing with the gas torch.
Okay.
Low power, low flame, very light. Just watch your heat, and again, after practice, you'll be able to see when that puddle forms. Start filling your filler rod in, and you just work your way along.
So in terms of building aircraft, there are some other areas that you'd use welding for. So aluminum, you might want to build a fuel tank, or maybe build some compound curve fairings and things.
We've had
restoration is more of that.
Yeah, if you look at some of the older aircraft that have these real elaborate compound curve cowlings and that, if you're repairing that or trying to duplicate that, a lot of times you're going to end up getting into aluminum welding. Yeah. And so you'll weld it, then you'll burnish that weld.
And that in itself is quite a process, because if you look at a simple wheel pant, that's literally made up of smaller segments.
Several different pieces.
That are welded together, and then the welds are finished out so you don't see them.
You don't even see them.
Yeah. So we have aluminum, we have steel, of course, and then there's stainless steel.
Yes.
So you might have the opportunity to do a stainless steel welding for like an exhaust system or something like that.
Yep, exactly.
So of the two, is Tig more suited for stainless steel?
Tig is definitely my friend in stainless steel.
Why is that?
It just does a nicer job, I find. Your shielding gas is there, so you get a good clean weld. You don't get any contaminants in it and that. You can control your heat so well, and you have again, you're going to use a proper filler rod, but it just seems to lend itself to me to stainless welding. It's just the Tig is the way to go. I'm sure you can do it with gas. I've never even tried it. Tig Machine is there. That's what I grab. So
sure.
So yeah.
So is there any downfalls to doing the welding yourself? I mean,
no, not at all.
Basically practice.
Practice is the thing. Again, this is a great place for you to involve your EAA technical counselor. Or maybe some other accomplished builders in your chapter. Use that EAA network together and draw on that knowledge that's already out there amongst your peers.
The local chapter here, EA 252 on Whitman Field here in Oshkosh, they actually have their own TIG welding course.
Yes,
and
exactly.
So they actually, for the chapter, and they'll go in and they have a TIG welder over there, and they'll gather in groups, and then occasionally we'll go through learning how to TIG weld. And then, of course, we have the EAA Sport Air workshops with our TIG welding course here and our gas welding course, too.
Exactly.
So those are good starting points, too.
Right, exactly. And like I say, just using that EAA network, whether it's the Sport Air workshops or your local chapter, is a great way to get yourself started on this. And again, with a TIG machine, there might be chapters that have a TIG machine that's kind of a community TIG machine that the individual members can borrow for a certain length of time and do their welding, or maybe bring their project. If it's a smaller part, they can bring it right to the hangar or whatever and do that. So a lot of ways that you can involve that EAA family and use those EAA resources to get involved with this without having to maybe just go into it blindly and start buying equipment and use those resources and make sure you're getting what you need and understanding what you're going to do with it.
And as we talk about resources, we've got some great books and videos on both gas welding and TIG welding. We have a step-by-step booklet that has been produced with articles. In fact, here's a copy of it right here. Articles and general information on how to do gas welding, collected from Sport Aviation over all the years. And we have a companion DVD, which goes through the basics of gas welding from start to finish, just learning the equipment. And so if you did want to do kind of a self-study course, you could do that.
We have that available.
So we have that available for gas welding. And we also have a very similar DVD that was produced here at EAA with our welding instructor, Wyatt Swaim, that went through all the aspects of TIG welding using the TIG machines that we have here. And we certainly appreciate the support of Lincoln Electric for supplying the equipment that we use for our EAA Sport Air Workshop's TIG welding course. That's been an amazing benefit to EAA members.
They've been a wonderful partner for us.
And over the years, doing the TIG welding workshop at Oshkosh
at convention,
too.
Yeah, exactly. So yeah, they've been a great partner for us.
Yeah, so a lot of great resources that way, and of course our hints for home builders too. Video resources. We have over 500 videos, and every week we upload one or two more.
They put a new one on just about every week, and there's a broad spectrum of information on that. So not only just welding, but all aspects of building your aircraft are covered in the hints for home builders.
So like we've talked about through this whole workshop series this week, is these things aren't that challenging. I mean, it looks hard. I mean, you've got a bunch of gauges and knobs and valves, and you've got this computerized box, but once you actually sit down and do it, it's really not that hard.
You'll find that it's not all that difficult, and it's enjoyable. You really feel, it's like, this is great. I'm actually doing this. I mean, it's just an amazing sense of accomplishment.
It really is. There's an amazing feeling when you've done something and then finish this up, and then you look at it and you go, wow, I did that.
Yeah, I put that together.
It's pretty cool.
It is very cool. Yep.
Great. Well, Joe, I'd like to say thanks for taking us through the whole welding process. I mean, the only welding I ever did was back in high school. We did arc welding with a big stick.
Old stick, yep.
Yeah, and like probably 1/2-inch plates.
Giant pieces. Yep.
This is amazing technology.
It's a lot of fun. It really is enjoyable. It's something that once you master the skill, you can just do it and do it and do it, and it's really fun to oh man, that's another great looking weld. It's really a sense of accomplishment when you get to that point.
Yeah, fantastic.
All it takes is practice.
All practice. Well, that's it for this workshop session today. We're coming back later this afternoon talking about sheet metal and the techniques with that. We'll be doing some solid riveting with our sheet metal course later on this afternoon. I'm Mark Force.
And I'm Joe Norris.
Here at EA Together, the Spirit of Aviation Week. Thanks, everyone, and we'll see you soon.